Imagine stepping onto Mars for the first time. The sky is butterscotch, the ground is rusty. The horizon feels closer because the planet is smaller. My first move? I look down at the rocks. Basalt, dust-cemented sandstone, ancient volcanic fragments, then up at two tiny moons inching across the sky. Let's make this a classroom-style tour. Mars sits about 1.5 times farther from the Sun than Earth, averaging roughly 228 million kilometers from the Sun. Earth and Mars swing closer and farther as they orbit at their best alignment, opposition. The distance can shrink to about 55 million kilometers. At their worst, it's more than 400 million. That gap sets our travel window, roughly every 26 months when fuel costs are lowest. A one-way trip takes about 6 to 9 months with current tech. Atmosphere first. Mars has a thin, mostly carbon dioxide atmosphere, about 1% of Earth's sea level pressure. That means no breathable air, weak sound, tricky landings. Too thin for parachutes alone, too thick to ignore. So landers use heat shields, parachutes, retro rockets, and sometimes sky cranes to touch down safely. What about day-to-day life? A Martian day, a sol, is 24 hours and 39 minutes. Close enough to Earth to keep a normal schedule. The planet tilts about 25 degrees, similar to Earth, so it has seasons, longer and colder ones. Average temperatures hover around 60 degrees C with wide swings, warmer near the equator at noon, brutal cold at night and in winter. Gravity is 38% of Earth's, so you'd weigh a little more than a third. Now the moons, Phobos and Deimos. They look like lumpy potatoes, likely captured asteroids or rubble formed after an ancient impact. Phobos orbits so close it rises in the west and sets in the east several times a day, and it's slowly spiraling inward. In tens of millions of years, it may break apart into a ring. Deimos is smaller and farther, drifting outward. Water? There's a lot to work with. Polar caps hold water ice and dry ice. Radar hints at buried glaciers and mid-latitude ice sheets. Some minerals lock away ancient water history. Liquid water on the surface today is unstable, but underground brines could exist. For settlers, ice means drinking water, oxygen via electrolysis, and even rocket fuel if you split water into hydrogen and oxygen. Stones from Earth, wonders on Mars? That's a poetic idea, bringing small pieces of Earth, say, a pebble from the Grand Canyon or a fragment of volcanic basalt from Hawaii, to mark humanity's first outpost. Scientifically, it's also useful for calibration. Known samples help rovers and labs compare measurements. Why go? Science. Ancient riverbeds and lake sediments may hold clues to past life. Survival. Becoming multiplanetary adds resilience. Innovation. Solving Mars problems. Closed-loop life support, efficient energy, radiation shielding, spins back into better tech on Earth. Opportunity. New jobs in habitat design, robotics, telemedicine, agriculture, resource extraction, from mining regolith for bricks to harvesting ice. Challenges are real. Radiation without a global magnetic field, dust that clings to everything, and isolation. Solutions include underground or regolith-covered habitats, water walls for shielding, nuclear or solar power with dust mitigation, and greenhouses with controlled pressure and light. If you move there, expect peach-colored days, star-crisp nights, and dust storms that can dim the sun for weeks. Expect routine. Grow food, recycle air and water. Fix what you have and explore carefully. Mars won't be easy, but the path is clear. Launch during favorable windows, land with precision, live inside pressurized shelters, and use local ice and rock to build a future. First footsteps, then neighborhoods, then a thriving science town under a sky with two tiny moons.